Hello my dear students, this is Akash SD and welcome to the ASD physics classes students. I hope so you all are doing really great. So students, in this video we are going to solve the question from the topic Ohm's law, okay? And we are going to see how the resistance of the wire is going to change when the wire is going to be the stretched. Okay students, so let's learn the concept through this video. So here you can see the question is the resistance of a wire is R0 ohm. What will be its new resistance R if it is stretched to n times of its original length. Okay, so here we have taken here the two situations, the wire before the stretching and the wire after the stretching. Okay, so let's take before the stretching, the resistance of the wire is R0, and after the stretching, the resistance of the wire is R according to the question. And let's take original length of the wire is L0, and after stretching the length is L. Okay, and according to the question we can write here this new length is equal to n times of the original length. Okay, so students, when the wire will stretch, what will happen? It will become thinner. That means area of cross section will decrease. Okay, so let's take for example here area of cross section is A0. Okay, and here this new area of cross section is A. Okay, so students, remember that here when the wire is stretched, anyhow the material will not change. That means here resistivity rho, here also resistivity rho. Even this resistivity is also called specific resistance, depends upon the nature and temperature of the material. Okay, first concept. Second concept is that when the wire is going to stretch, the volume is not going to change. What will happen? The volume remains constant. So what we'll write here? We'll write here as volume remains constant. Okay, so we can write here this A into L. This is the new volume, and original volume how much is there? It is the A into L naught. Okay students, so from here if I write here A naught by A, what is A naught by A will become here? You can see from here it will become here L by L naught. And from here you can see the L by L naught is how much is there? See, it will be used actually. So see, L by L naught will be how much here? N. This is, so here also we can write here this is the N. Now kindly remember that this thing is there. After that students, if we talk about here the resistance, so what is the resistance formula? Kindly think and tell. The resistance is given by R equal to rho L by A. Okay, so what I am going to write here? I am going to write here students this resistance ratio. So see, R by R naught is given by R means we can write here rho into L by A. Is it? New resistance and original resistance how much is there? Rho L naught by A naught. Is it? So anyhow what will happen that here? This rho and rho will cancel out, and we can write here this is the L by L naught into A naught by A. Is it? Now we can write here, see here, this R by R naught is given by, what is the L by L naught value? See here, this L by L naught means N, and A naught by A also how much here? N. Is it? So this value we are going to put here. Even L by L naught is the N, and A naught by A also how much students here? This is also N. So we can write here this resistance is given here N square into R naught. What is the resistance here? After stretching, the resistance is going to become N square R naught. Okay. After that, one more thing, please remember that here they used to ask a percentage increase in resistance, or we may tell percentage change in resistance. Okay, resistance. Now, so what this will become here? Percentage change means we can write here delta R by R. Delta R is given by R minus R naught with respect to original into 100. Okay, see here. Now, delta R by original resistance R naught. Then we can write here this is the R by R naught minus 1 into 100. Is it? And from here what is this? R by R naught means N square. Is it? So we can write here the formula N square minus 1 into 100. So whenever they are asking percentage change, kindly remember this formula, you will get all the answers. Okay, so students, we have understood very well when the length is becoming N times, the resistance is going to become how much here? N square times. But now here we are going to see in terms of the radius. Okay, so in this question what is happening? Actually the concept. So see here, the resistance of a wire is R0 ohm. What will be its new resistance R if it is stretched to 1 by n times of its original radius. Now they are talking in terms of the radius. So see here, students, let's take here. The original resistance is R naught and the new resistance is R. Okay, and let's take here again. Original length is the L naught and the new length is L. Okay, but now what is given here, students? It is given here. Let's take this the radius. This I am telling you, this radius, not this radius. If I draw here like this radius is how much is there? R naught. And this radius, this radius how much is given here? R. Okay, so according to the question, what they are telling that here, this new radius is going to become R naught by n. If in case the radius is becoming half after stretching, the value of n will be 2. Okay, if the radius is becoming 1 by third, the value of n will be 3. Have to be very careful. And as I have told you, students, the material is not going to change. That means I can write here resistivity rho, here also resistivity rho. Okay, and after that, the second concept, volume is a constant. Now, whenever the stretching will happen, what will happen? Volume is constant. So as volume is constant, we can write here again A into L naught, now, as we have done before. So from here, students, if I write here, see here, this A naught by A will become what? This A naught by A will become here, see, L by L naught, is it? Or we can tell here, see, this L by L naught is given here, A naught value, na, circular cross section. So we can write here, see, pi R naught square by pi R square. Okay, so we can tell here this is the R naught by R whole square. What is this? R naught by R whole square. Now tell me from here, this R naught by R, how much is there? If you see from here, this R naught by R value, students, it will be n. Now can you see very well how we have done this? Is it? So we can write here, see, this L by L naught is given by how much is there? Put here R naught by R n. So students, it will become here n square. What is becoming? N square. So this thing kindly remember that here, and this thing also kindly remember that. See how I have got it R naught by R and how I have got it L by L naught also. Now again, what we'll do here? Here students, again we'll write here the ratio. So see here, if I write here, see, R by R naught is equal to, again formula, see, rho L by A, and here rho L naught by A naught. So students, what will cancel out? What will cancel out? See here, this rho and rho cancel. So we can write here, see, this L by L naught into, what we can write here, A by A naught. Is it correct? L by L naught, and no, mistake happened. What mistake happened? A naught by A. Now A naught by A. Now I have to be very careful. After that we can write here, see, this is the L by L naught, and this is given by what we have written here, this R naught by R whole square. Is it? Because pi and pi will cancel out. Is it? So students, we can write here, see, again this R by R naught is given here. You can see very well L by L naught, how much we have got here? This L by L naught is how much here? N square, and R naught by R is N. Okay, so we are going to put here, this is going to be the N square, and this R naught by R, how much here? N, and here this is square, so here also is square. So students, you can see here what we are going to see here. Finally, we are going to see here R equal to N to the power 4 R naught. If they are talking in terms of the radius, it is going to become N to the power 4. Okay, and if in case they ask here, as I have told you, percentage increase in resistance, percentage increase in resistance. Okay, so again, what I will write here, see, R by R naught minus 1 into 100, na? Because before also I have done it. Is it? That means it will become here N to the power 4 minus 1 into 100. Is it? Can you see very well how we have done this? Is it? So students, without getting confused, remember that here I am just writing here, if in case, what is this? This length they are telling L equal to NL naught. Okay, so in this situation the resistance will be how much here? N square R naught. Okay, and if in case they talked in terms of the radius, like R equal to R naught by N, then what is going to the resistance here, students? What is going to the resistance? It is given here N to the power 4 into N to the power 4 into how much? R naught. Okay students, so this formula should be remember that. Kindly see here very well, even I have written here the summary also. Okay, because very important concept, that's why. Is it? Now students, after that we are going to see here one question. So you can see here the question came in a NEET 2013 also, same concept came in a JEE also. Okay, so see the question. A wire of resistance 4 ohm is stretched to twice its original length. The resistance of stretched wire would be how much? Okay, so if we talk about here the original resistance, how much is there? R naught value, kindly see here students, 4 ohm, is it? And after that length is going to become how much? See in the question here, twice, is it? That means we can write here students here, this n value is the twice, is it? Now see here, we know that what is the formula? N R equal to n square R naught, correct? N value 2, that means 2 square, and R naught value how much is there? 4. So 4 into 4 how much is coming here? 16 ohm. So you can see here which option is correct here. The correct option is here option D. Kindly see here very well. This question came 2013 also and JEE 2023 also. The concept was same. Same formula. Okay. After that, now see here please. Now we are talking. In this question, it is given based upon the percentage. So see here, if a copper wire is stretched to increase its length by 20%, the percentage increase in resistance of the wire is how much is there? Okay, so here they are talking about in terms of the percentage. Okay, so see here, this new length is given here, original length plus how much increased students here? 20%. Okay, so we can write here, see, 20% of L. 20% of L. That means we can write here 20% of L naught actually. Okay, so L naught plus 20 by 100 into L naught. Then we can write here L naught plus 0.2 L naught. Hence, you can see students, this L is given here how much? 1.2 L naught. Is it? And if in case students, you are going to compare this, now you are going to compare this with L equal to N L naught. Then what is the value of N? The value of N is going to be student 1.2. Is it? So after that, in the question, what they are asking? Percentage increase in resistance. So students, I have told you the formula. Percentage increase in resistance. What is the formula? Just guess it. It was n square minus 1 into 100. So 1.2 square means, here I am going to write here, see here, 1.2 square minus 1 into 100. Okay, so it will become here 1.44 minus 1. Is it? 1.44 minus 1 into 100. Because this basic we have to use, that's why we are doing here. Okay, so see here, 0.44 into 100. So it will come here, how much students here? The 44%. What is the answer here? It is going to be here 44%. Okay, kindly see here very well in how much beautiful way we have done this. When the length is increased by 20%, the resistance is going to be increased by how much here? 44%. Okay, great. Now students, this table we are going to fill because very important here now. So see here, percentage increase in length, first column, L equal to NL naught, second column, and percentage increase of resistance, it is going to be the third column. So see here, as I have taught you, if this is the 20%, what L was there? L was 1.2 L naught. Okay, and it has become how much students here? This has become here 44%. Okay, if in case students, this is given here 10%, then what will happen that here? Just think in the same way, it will become here 1.2 L naught. Okay, and what is the value of the N? 1.1. You will write here 1.1 square minus 1 into 100. So it will become here what? 1.1 square means 1.21 minus 1 into 100. So when you will simplify this, 0.21 into 100, and it will become at the end 21%. Okay, so in the same way, remember that here, this is how much here? 21%. Similarly here, 30% means students, it will become here 1.3 L naught. Okay, and when you will simplify in the same way, it will come here 69%. Okay, if in case it is given here, let's take for example 40%, then what this will become here? L equal to 1.4 L naught. Okay, and you will do 1.4 square minus 1 into 100, so it will come here students here 96%. Okay, if in case they have given here the 50%, then what will be L? 1.5 L naught, and again 1.5 square minus 1 into 100, 2.25 minus 1 into 100. Okay, so 1.25 into 100, so it will come here 125%. Is it? So students, I hope so. Kindly see here very well now. So students, I hope so this video you have understood very well now how the stretching is going to affect the resistance of the wire. Students, keep studying, keep growing.